All right, everyone, let's get the show started. Welcome to Office Hours. It's February 5th, 2020. My name is Eric Osterman, and I'll be leading the conversation. I'm the CEO and founder of Cloud Posse. We are a DevOps accelerator. We help startups own their infrastructure by building it for you and then showing you the ropes. For those of you new to the call, the format is very informal. My goal is to get your questions answered, so feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or on our YouTube channel, you can register for these live and interactive sessions by going to cloudposse.com/office hours. We host these calls every week, and we'll automatically post a video recording of this session to the Office Hours channel, as well as follow up with an email so you can share it with your team. If you want to share something in private, just ask and we can temporarily suspend the recording. And with that said, let's kick it off. So I don't have really any demos prepared for today or more interesting talking points. One of the things that we didn't get to cover on the last call were maybe what some of the interesting DevOps interview questions are. You know, what are some of your favorites? Interestingly enough, this has come up a couple times lately in the jobs channel, either people going in for hiring or people using some of these questions in their recent interviews. So I'd like to hear how that went. Brian Ty, who's a regular, and let's see, he hasn't joined yet, so we'll probably cover that as soon as he joins. He has been working on adopting Prometheus with Grafana on EFS, but he has a very unique use case compared to others. He does ephemeral blue-green clusters for their environments, and he's had a challenge using like the EFS provisioner on ephemeral clusters, so he needs a different strategy. So I was going to talk about what that strategy could look like, but I'm going to wait until.
Hey, real quick, Eric. This is Andrew. I work with Brian. I'll grab him and let him know.
Okay, awesome. Thanks. Awesome. Oh yeah, Andrew Elkins, cool. All right. In the meantime, let's turn the mic over. Anybody else have some questions, something interesting they're working on, something they want to share? It's really open-ended.
Well, I'm putting together. I've been doing this as a skunkworks at the office for the last couple of months, but I'm putting together like a showcase of open source DevOps. They don't have to be open source, but DevOps tools.
Okay.
So if anybody has something they want to contribute or any experiments they want to run or anything like that, they're welcome to do that.
Cool. Can you just mention that in the Office Hours channel so that they know how to reach you? Yeah. So, Mike, I'm going to put you on the spot here. What are you working on? How'd you end up ending up in our Slack team?
Yeah, so we at my company recently started using Terraform, and we found the Cloud Posse templates to be very helpful, especially when learning it all. Yeah. And so I just came here to kind of find out some best practices beyond what's available online, and a bunch of us on our team actually read the Terraform Up and Running second edition.
Yep, that's a good book. Yeah.
Yeah. So we're just trying, or me specifically, I'm just trying to find best practices, and I guess one of my questions was going to be, how does everybody kind of lay out their Terraform? Like, I understand the concept of modules being reusable, but next step is like defining different environments. So like we're going to be using separate AWS accounts for different environments. And so just wanted to get some more expert advice from you guys, or just learn more about DevOps in general. And
yeah,
such a broad definition, or nobody has an accurate, or everybody has their own definition of DevOps. So
yeah, it's a loaded word.
We don't even have to talk about that.
Yeah, let's not go there.
That's a black hole.
So yeah, it's a hot topic. I'm sure a lot of people here can share kind of what their structure is. There's no like canonical source of truth, and I would also like to say that there has been a pretty standardized convention for how to lay out projects for Terraform that I think is being challenged with the release of Terraform Cloud. And what I want to point out here is that, the HashiCorp docs have gotten a lot better. especially like becoming a little bit more opinionated or idiomatic on how to arrange things. And that's a good thing because, you know, they're the maintainers of it. So one of the things I came across a few months ago when I was looking to explain this to a customer was what the different strategies were. And here they kind of lay out, for example, the common repo architectures as my mouse hangs and I can't scroll down. This is the problem of screen sharing with Duet, maybe. All right, I'll wait for that to wake up and continue talking. What it lays out here is basically 3 strategies. One is the strategy basically that HashiCorp is now recommending, which you can briefly see at the top of my screen here, which is using a monorepo or using kind of poly monorepos. What I mean by that is breaking it out maybe by purpose. So maybe you have one repository for networking, one repository for some Teams project or something like that. But what you do is you don't have environment. Man, let me see here if I can. Ah, here we go. It's waking up as my mouse is going crazy. All right, there we go. So multiple workspaces per repo. So what HashiCorp started doing was saying, hey, let's use the workspaces concept for environments, even though originally they said in their documentation, don't use workspaces this way. So I don't know if you saw that anywhere, but now they've done a mea culpa on that in About Face. And we've been taking a second look at this, and I think that it's making projects a lot easier actually for developers to understand when you just have the code and you just have the configuration and you don't conflate the two. So the other approach is like, you know, more traditional in development. You have maybe a branch for each environment. This is a controversial thing as well. I don't like it because you have long-lived branches and keeping them in sync and merge conflicts and managing that they don't diverge is not, it still takes extra effort. Also, if you're an organization that believes in trunk-based development, then the branch, long-lived branches like this isn't ideal. And then there's the directory structure. And this is what I was going to get to. Is like, this has been the canonical way of organizing Terraform projects. Maybe in large part because, you know, Gruntworks has a lot of influence in this area. And with the usage of TerraGrunt and tools like that, this has been a good way of doing it. But there's some problems with this. So what I like about it, first of all, is you have a separate modules folder, right? And the modules folder has your what we call root modules, that top-level invocations, and those are reusable. That's like your service catalog that developers use. And then you have your environments here, and those kind of describe everything that you have for production, everything that you have for staging. And like these might be broken out more. Like you should have project folders under prod. You wouldn't have this would be considered like a monolithic project or teralith. You don't want teraliths, right? So under prod, you would maybe have VPC, and you'd have maybe EKS, and you'd have maybe some other project or service that you have. And then under there, all the Terraform code. The problem is that these things still end up diverging because you have to remember to open pull requests to promote those changes to all the environments, or you have to create one heavy pull request that modifies all those environments. This has been a big pain for us, even at Cloud Posse. So we started off with an interesting approach at Cloud Posse, which is to organize accounts, treat accounts like applications. And in that case, when I say accounts, I mean Amazon accounts. So like the root account or your master account is one configuration. You have your staging configuration, your corp configuration, your data configuration. And what I love about this is you have like a strict share nothing approach. Even the Git history shares nothing. And you know, share nothing has kind of been this holy grail to reduce the blast radius. The other thing is like when your webhooks fire, they only fire on the dev account. And because we have these strict partitions, there's no accidental mistakes of updating the wrong environment. And every change is explicit. Now, there's a great quote in a podcast that just came out the other week, whatever, the Changelog, and they interview Kelsey Hightower on like, I think the topic was like, the future is monoliths. And yeah, this is the constant battle of bundling and unbundling. Bundling and unbundling is like, basically, I guess, to get anywhere, you got to consolidate and then expand. And then you expand and you realize that didn't work well. You reconsolidate and you re-expand in a new way. So I don't know. But my point here was more like, one of the things he said, and that was like, the problem with microservices is that it requires the developers to have a certain like level of rigor. I mean, this is paraphrasing my own words. And it's asking it in an organization that wasn't practicing it before, so how are they going to get it right this time by moving to microservices? I want to find the exact quote somewhere. Maybe somebody can post it to Office Hours if they have it handy, but that was it. So that's the thing here. What I describe here, this is beautiful. And when you have a well-oiled machine that is excellent at keeping track of promoting changes to all your environments and no changes left behind, then it works well. But this is an unrealistic expectation. So that's why we're considering the HashiCorp recommended best practice now under using multiple workspaces per repo. And under this model, when you open up a pull request, kind of what you see is, okay, here's what's going to happen in production staging and anywhere else you're using that code. Because inadvertently, you might have drift. Either from human monkey patching going into the console, or that maybe applies failed in some environment and that was never addressed. So now you have diverged that way. That's a valid error. Or maybe you have other Terraform code that has imported the state or something and is manipulating those same resources. Anyways, there's been bugs in Terraform providers and all that stuff. So I want to see, when I open up a pull request, what's going to happen to all those environments. And that's what I really like about this workspace approach.
I feel like that's the opinion we keep getting. Like, we'll see people that broke it out in a similar way that I think you had in Cat Home Experts, where you'll have like the different AWS accounts. And then now it's interesting to me that you're like, well, now we're going to try this multiple workspaces. So it's like, where do I go? Where do you go from here? Yeah.
And you're right to feel frustrated. And the ecosystem.
This isn't frustration towards you.
No, I know. It just in general. And I would say, like, in software development, more or less the best practices for how to do your pipelines and promote code is very well understood. And we're trying to adapt some of those same things to infrastructure. The problem is that we're operating at different points in the software development lifecycle. And the capabilities at our disposal are different. So let's take, for example, infrastructure. Infrastructure, if you listen to this podcast or you talk to us, I always talk about this. It's like the 4 layers of infrastructure. You got your foundational infrastructure, you got your shared services. You got your platform, and then on top of your platform, you got your shared services, and then the last layer is your applications. Most people working with this stuff assume layers 1 through 3 exist and don't have to worry about it. It's a separation of concerns. All they care about is deploying their app. They don't have any sympathy or empathy for how you manage layers 1 through 3. But if you're in our industry, that's one of the biggest problems, is that we have to maintain stability of the platform while also providing the ability to run multiple environments for developers and stuff like that. So my reason for bringing up all of this is that, like, Terraform as a tool doesn't work like deploying your standard microservice, your standard Go, Rails, Node app, or whatever. Like, if you deploy a Node app and it fails, you can roll back, or you didn't even need to expose that error at all because your health checks caught it and you were running parallel versions of all that software, et cetera. When you're dealing with infrastructure and using a tool like Terraform, it's a lot more like doing database migrations without transactions. So there is no recourse. So how do you operate when you're dealing with this really critical stuff in a place where you have poor recourse? So you need good processes for that. And let's see here. So That's why we're still trying to figure this out, I think, as it relates to DevOps. What is the best course of action? There's been Atlantis. There's been Terraform Cloud. A lot of people are using Jenkins to roll this out. Some people combine things like Spinnaker to orchestrate the whole workflow, because the problem is you're spanning CICD systems, and the answer for this, I don't think there is a, I don't think anybody's just nailed it yet. We're all figuring it out.
So can I just ask a question? If you go back to your cat home experts, and I don't know if you can, but click on one of those accounts. I'm just curious, now are you still referring to the Cloud Posse modules, or do you build out modules within here? Or no, this is all just config?
Both. So let me describe that a little bit more, what our strategy has been, kind of like food for thought. So here I have one of these AWS accounts, and under conf, we have the projects. So this is how we have kind of like the microservices of Terraform. So it's not a monolith. It's microservice architecture, so to say. And if I look in at any one of these, we've been using a pattern similar to what like you get with Gruntworks, which is where you have a centralized module repository. So here we have the Terraform root modules in Cloud Posse. So where you pull those root modules from really doesn't matter. Like you could have a centralized service catalog at Cloud Posse, which works well for our customers because their customers are implementing, our customers are implementing our way of doing it. Now, if, depending on how much experience and opinions you have about this stuff, you could fork our root modules, you could start your own. And what we have typically is the customer has their own root modules, we have our own root modules, and you kind of pick and choose from those. Here what we have is we're using environment variables with Terraform, which this pattern worked really well in Terraform 0.11, but in Terraform 0.12, for example, Terraform broke a fundamental way we were using the product. So when you run Terraform init -from module and you point at a module, you used to be able to initialize your current working directory with a remote module, even if your working directory had a dot file in it. So that worked really awesome. We didn't need any wrappers. We didn't need any tools. But then Terraform 0.12 comes out and they say, no, the directory has to be empty. Oh, and by the way, many Terraform commands, like Terraform output, don't allow you to specify where your state directory is so that it could get the outputs. So most commands, you can say Terraform plan in this directory, Terraform apply, this plan file, or in this directory, Terraform init in this directory. But other commands like Terraform show, I think, and Terraform graph, and Terraform output don't allow you to specify the directory. So there's an inconsistency in the interface of Terraform, and then they broke the ability to initialize the local directory. So anyways, my point with this is saying perhaps there's some confusion on our side as well because the interface was changed underneath us. So going back to your question under here, so then if you go to this folder here and you go to like Terraform root modules. Here are a bunch of opinionated implementations of modules for this company. So here's the idea. As the company grows in sophistication, you're going to have more opinions on how you're going to do EMR, how you're going to do Postgres, how you do all those things, and that's the purpose of this. And then a developer, all they need to know is that, look, I can follow best practices if I point to that. And then your DevOps teams or people, stakeholders in that with that label, so to say, can be deciding what are the best practices for implementing those modules. And then I don't know if you've seen Cloud Posse, then here we have our Terraform root modules. Now, our root modules, I want to prefix this with, we have these as kind of boilerplate examples for how to implement common things, but they're not necessarily the canonical best practice for implementing EKS. So our EKS root module here implements a basic EKS cluster with a single auto scale group, basically a single node pool. Now that gets complicated, right? Because certain companies, they're going to need a node pool with GPUs. and they're going to need a high memory node pool. They're going to need a high CPU node pool, and how you mix and match that. That's too opinionated for us to generalize.
Yeah.
Cool. Let's see.
All I can say is, yeah. No, I get it. And and that's kind of what we're going through now, just figuring out what works for us, deciding on the different structures of everything, and definitely taking advantage, or looking at what you guys have already done and looking at a lot of things and just reading all over. So
yeah, lots of good Reddit posts. Everyone happens to blog on Medium, so check out Medium.
Exactly. And I think that's the other thing, is just finding documentation on 0.12 compared to 0.11, and refining my Google searches and only searching the past like 5 months type of thing.
Yeah, it's a good point. Yeah, you can end up on a lot of outdated stuff, especially with how fast this stuff moves. So
yeah, like I was reading a blog from July of 2019 and blindly assumed that they were talking about 0.12 when in fact they were talking about 0.11. So
yeah, but
that's weird. That's all.
Cool. So I'm going to move on to the next question. I see Brian Ty joined us. He's over at Audit Board, and he's been working on setting up Prometheus on with EFS on ephemeral short-lived clusters. Kind of an interesting problem. Those of you who attended the last few calls, this Prometheus EFS thing has come up quite a lot. I want to just kind of tee this question up a little bit and frame it for everyone. So we at Cloud Posse, we've been supporting a lot of different monitoring solutions, but we always come back to that. Prometheus with Grafana is pretty awesome for Kubernetes. Community provides a lot of nice dashboards, and it's proven to scale. So one of the patterns we've been using that others here have used as well, that works pretty well, is to actually host the Prometheus time series database on EFS. And I guess your mileage will vary, and if you're running Facebook scale, yeah, you're probably going to need to use Thanos or whatever, some bigger thing. But EFS is highly scalable, it's POSIX compliant, and it works ridiculously well with Prometheus for a simple implementation. The problem that Brian has is his clusters are totally ephemeral. Like when they do a rollout, they bring up a whole new cluster and deploy their whole new stack to that, and then verify that, validate that works, and shut down the old one. And with Prometheus and EFS, what we've been using is the EFS provisioner. And with the EFS provisioner, it'll automatically allocate a PVC, a persistent volume claim, on your EFS file system. Problem is, those file system IDs are unique. They're generated by the Kubernetes platform. So if you have ephemeral clusters, how do you reattach that EFS file system if you're using the EFS provisioner? Well, the kicker is, if you are doing it this way, well, then maybe the EFS provisioner isn't the right tool. You can still use EFS, but the provisioner isn't going to be the right tool. And instead, what you're going to need to do is mount the EFS file systems to the hosts using traditional methods of mounting EFS for your operating system. So if you're using COPS, you're going to use the hooks for when the service starts up, and add a systemd hook that's going to mount that EFS file system to the host OS. And now with Kubernetes, what you can do is you can have you can mount the actual host volume that's been mounted there into your container, and then what you're naming, you are the decider of the naming convention at that point, and how you keep it secure and everything else. Brian, is that clear? I can talk more on that.
Yeah, no, that makes sense. Yeah, it's unfortunate that I have to go that route, but sometimes you don't get the turnkey solution.
Yeah, and I mean, so before the EFS provisioner, we were using this pattern like on CoreOS with Kubernetes for some time, and it worked okay. So I just wanted to point out, for those who are not familiar with the COPS manifest and the capabilities of the COPS manifest. So under Cloud Posse reference architectures is kind of what we've been using in our consulting engagements. to implement Kubernetes clusters with kops. I'm mostly speaking here to you, Mike, who was looking for like inspiration. This here is doing that poly repo architecture, which I'm undecided on at this point from being totally gung-ho on. Anyways, so we go back. so we go here now to the kops private topology, which is our manifest for kops. What I love about kops is kops basically implemented a Kubernetes-like API for managing Kubernetes itself. So if you looked at Kubernetes CRDs, they're almost the same as these. But then there's this escape hatch that works really well, is that you can define systemd units at startup that get installed. So here Brian, you'll create a systemd unit that just calls exec start to mount the file system, the EFS file system.
Yeah. Have you guys looked at EFS CSI driver?
No. So maybe there's more elegant implementations like that.
I pasted it in the chat, but it was what I was looking into next, which I believe could solve my problem for me just because I create the PV itself. Then I can define the path for that persistent volume.
Okay. Yeah, if you can define a predictable path, then you're around it.
Yeah.
It's just as long as you're in the territory of having random IDs, then
yeah. I believe if I'm creating the persistent volume myself instead of doing the PVC route, then I can create the volume, and then when I'm provisioning Prometheus, I can just tell it which volume to mount instead of going and creating a PVC through Prometheus operator.
Okay.
I think that's the route I'm going to try first. If not, then obviously the COP systemd one is the one that for sure will work.
Yeah, that's plan B. So, yeah. Andrew Roth, you might have some experience on this area. Do you have anything to add to it?
I've never used the CSI driver. I've only used EFS Provisioner.
Okay, and Dale, our very own certified Kubernetes administrator, any insight here?
Yeah, well, your initial thought was the train I was acting on to have the host itself be attached and then have the container mount that from there. Yeah.
Have you used the CSI driver before?
I've only just started to mess around with it.
Okay.
With not enough experience to really say anything. I'm actually playing around with the Rook Ceph with it. Yeah. That's it.
All right, cool. All right, well, I guess that's the end of that question then, unless you have any other thing you wanted to add to that, Brian.
Nope.
All right.
Thank you.
Cool. Yeah, any other questions? We got quite a lot of people on the call.
I just have a general question. It's Warren. So I know in the company that I work for, we use a lot of you guys' repos, and cool. I know a lot of it is revolving around AWS. Now, do y'all have any, or do y'all plan on doing any repos for like maybe DigitalOcean?
That's a good question. So fun fact is that we use a bit of DigitalOcean kind of for our own POCs to keep our costs low and manageable. I don't know if we're going to really be investing directly in DigitalOcean because of who we cater towards, which are more like well-heeled startups, and they need serious infrastructure. So I think DigitalOcean is awesome for POCs, but I wouldn't want to base my $100 million startup on it.
Cool. I do have like a little comment also. We actually do use that process of using the Terraform Cloud with the workspaces.
Oh, cool. How has that been working out for you? Anything you want to add, like for a use case or firsthand experience?
So far, it's pretty good. You know, anytime we have any issues with a certain, I guess, stage, we just have to do a pull request to that particular stage.
Okay.
And, you know, just go from there. And it's pretty simple, you know, because I've only been involved with the company with a little over a year. So
which of the repo strategies are you guys using with Terraform Cloud?
The repo strategy, I guess, depending on the stage, or so like we have stages like prod, dev, UAT, QA. So like maybe UAT and support, they'll branch off from the master branch.
Okay, so you're using the branching strategy then, where UAT would be a separate branch?
Not in the Git repo. It'll all be on the same branch in the Git repo.
Okay, so
but anything that's merged into master.
Are you using folder structures then, or are you using the official approach that they describe up here?
Hold on one second.
It sounds like a single branch, like a master. They branch from that and then merge back in.
Yes.
So there's nothing long running.
Yeah, but are the environments, is UAT just a workspace, or is UAT a project folder like this?
UAT will just be a workspace.
Okay, cool. So yeah, you're using that strategy, the first strategy we were talking about here. Multiple workspaces for repo. Cool.
I wanted to expand on that in that we have an older Terraform repo that has a few of them that are using workspaces, but we have a lot of stuff that we're doing TerraGrunt to manage it. And I haven't sat down really to think about it, but is there a best practice for managing workspaces via TerraGrunt?
I was exploring that the other day, just in terms of a POC, and out of the box, TerraGrunt does not support workspaces. It's a anti-pattern for them, and I would say that, like, you know, based on what I said earlier, that used to be the official anti-pattern. Like, you don't use workspaces for this, but even HashiCorp has done an about face on this. So TerraGrunt, I'm not sure if they're going to be adding support for it or merging or even addressing this topic. However, I was kind of able to get it to work using, and I don't know what the term was in TerraGrunt, but I think the equivalent of hooks, right? So I had what was it?
Prerequisite?
Yeah. Either for the plan or the init or whatever, I just used a hook to select the workspace and then create the workspace if the selecting failed, and that seemed to more or less work for me. So the challenge is you need to call this other command, which is Terraform workspace select or Terraform workspace new, and using the hooks was one way to achieve that. Let me see here. I'm gonna, in a terminal window, I might still have that.
I have a question on those using Terraform workspaces.
Yep.
I haven't been keeping too up to date with Terraform 12. Have they made the change so that you can interpolate your state as your state like location, or
nope.
Is that still not a thing?
That's still not a thing. I could talk to that as well, actually. Another mea culpa, kind of. So okay, so for everyone's clarification, let's see here. That's a good example. So the Terraform state backend with S3 requires a number of parameters, like the bucket name, the role you need to assume to use that bucket, key prefixes, all that kind of stuff. And one thing that we've been practicing at Cloud Posse has been this thing like share nothing, right? So here's an example, what Brian's talking about. So you see this bucket name here, you see this key prefix here, you see the region. Well, in the share nothing approach, right, you really don't want to share this bucket. especially if you're having a multi-region architecture and you want to be able to administer multiple regions in the event one region is down, you definitely have to have multiple state buckets, right? However, because Terraform to this day does not support interpolation, basically using variables for this, that's kind of limited how you can initialize the backend. So one of the things that they introduced in a relatively late version of Terraform, like Terraform 0.9 or something, I don't know, was the ability to set all the backend parameters with command line arguments. So you could say Terraform init, and I think the argument was like -config, and then backend equals bucket equals whatever, I don't know, something like that. And then, but then there was still no way to like standardize that. So that's why at Cloud Posse we were using environment. There's this thing that you can use. I'm just going to type it out here. So Terraform supports certain environment variables. So you could say export tf_cli arg. It's kind of weird. tf_cli plan args, I think it was. And then equals, and then here you could say like dash backend config equals bucket equals like my bucket. So because you had environment variables, you could kind of get around the fact that you couldn't use interpolation. Now, are we clear up to this point before I kind of do my soul searching moment here?
For me, this is clear. Yeah.
Okay. So
I'm just one voice.
Hey, Eric, are you trying to share your screen?
Yeah, you might need to. It's definitely being shared because I see the green arrow around my window. You might need, if you're in Zoom, you might need to tab around to see it.
Yeah, I can see it, definitely.
Yeah, I could.
Yeah. Zoom is funky like that. Like,
I see it now.
okay. Yeah. So you see here, like I might be off by some capitalization here somewhere maybe, but it is more or less what you can do to get around it. So you could stick that in an nvarc, you could stick that in your make file, you could have users, you could have it in your wrapper script. Okay, and then the last option, yeah, if you're using TerraGrunt will help set this up for you by passing these arguments for you in your TerraGrunt.hcl file. So there are options, right? But a lot of these are self-inflicted problems based on problems that we have created, like I said, self-inflicted problems we've created for ourselves, right? The problem we created for ourselves at Cloud Posse was this strict adherence to do not share the Terraform state bucket across stages and accounts. Always provision a new one. This made it very difficult when you wanted to spin up a new account because you had to wire up the state. In managing Terraform state with Terraform, we have a TF state backend module. We use it all the time. It works, but it's kind of messy when you got to initialize Terraform state without Terraform state using the module. So it creates the bucket, the DynamoDB table, and all that stuff. Then you run some commands via script to import that into Terraform. And now you can use Terraform the way it was meant to use with this bucket that was created by Terraform. But it's really, you see the catch-22 here. And if you're doing this in every account, is that ideal? So Gruntworks took a different approach with TerraGrunt. And in TerraGrunt, they have the tool, TerraGrunt, provision the DynamoDB backend and the S3 bucket for you. So it's kind of ironic that your whole purpose with using Terraform is to provision your infrastructure as code, and then they're using this escape hatch to create the bucket for you. And so let's just say that was a necessary evil. I'm not, I get it. It's a necessary evil. Well, on the topic of necessary evils, let's talk about the alternative to this, to eliminate like all this grief that we've been having. Screw it. Single state bucket, and just use IAM policies on path prefixes, on workspaces to keep things secure. The downside is, yes, we got to use IAM policies and make sure that there's never any problems with those policies, or we can leak state. But it makes everything 10x, 100x easier. It's like using, so one of the things Terraform Cloud came out with was managed state, and that's free forever or whatever, if you believe it. But just having the managed state made a lot of things easier with Terraform Cloud. I still like the idea of having control over it with Terraform in S3 on Amazon, where we manage all the policies and access to that. So that's why we're doing that. All right, so when you're then using workspaces together with this state storage bucket, the other thing you got to keep in mind is using this extra parameter here. So workspace key prefix. So if you're using the shared S3 bucket strategy, then you're going to want to always make sure you set the workspace key prefix so that you can properly control IAM permissions in that bucket based on workspaces. So a workspace might be dev, a workspace might be prod, stuff like that.
Thank you for explaining that. That definitely cleared up some confusion, especially when it comes to workspaces. And like you said, where do you keep the state? But if you divide that all up with IAM roles and policies, it can be done by keeping it in that single state.
Yeah.
Single bucket, I should say.
So one of the things why we haven't liked this approach is that, okay, how do you say? Okay, and I want to correct one thing. I was kind of saying it wrong or misleading. So the workspace key prefix would be kind of your project. So if your project is EKS, the workspace key prefix would be EKS. And then Terraform automatically creates a folder within there for every workspace. So there'll be a workspace folder for prod, a workspace folder for dev, etc. Okay, so cleared that up. Now, why we haven't liked this approach is so IAM is a production grade, or sorry, we're using IAM in production. And let's say this bucket is in our master AWS account. And we're using IAM there. And we're using IAM to control access to dev, or control access to staging workspaces, or control access to some arbitrary number of workspaces. Well, what we're actually doing is we are modifying production IAM policies without ever testing those IAM policies in another environment by procedure. Like, we're not enforcing, you can still test these things, but it's on your own accord that you're testing that somewhere else. And that's what I don't like about it, is that you're kind of doing the equivalent of cowboy IAM in production. Obviously with Terraform as code, but nonetheless in production.
You almost need a directory server for this sort of thing.
Yeah, that'd be that's interesting. I don't know, is there a IAM directory integration? I haven't looked trying to do that, but yeah. So sorry, once again, some comments here by Alex. But if you update the referenced version in dev, but then get pulled away and it gets forgotten later, and environments come back to it, it's like diff work. So then coming back and being like, what have we dropped the ball on? Requires some fancy diff work and just tedious investigation. I kind of want a dashboard that tells me what version of every module I'm referencing in each environment. This doesn't cover everything, but doing cool stuff like this is just messy. So yeah, so Alex Siegman is actually one of our recent customers in one of our recent engagements, and I'm not. So one of the problems that we have in our current approach that we've been doing, which we've done up to this point, has been that you might merge PRs for dev and apply those in dev, but those never get promoted. Those changes never get promoted through the pipeline, and then they get lost and abandoned. And that is the whole problem with what I argue is that with both the poly repo approach that we've been taking, but it's also the problem with the directory structure approach That's been the canonical way of doing things in Terraform for some time. The prod directory, the dev directory. All of those things have the same problem, which you forget what's been rolled out. So that's why I like this approach where you have one PR and you never, okay, there's variations of this implementation. One variation one is that PR is never merged until there's an successful apply in every environment. So then that PR is that dashboard that Alex is talking about. He wants a dashboard that tells what version's been deployed everywhere. Well, this is kind of like that dashboard. When that PR is open, then you know that there's an inconsistency across environments, and based on status checks in your pull request, you see success in dev, success in staging, and no update from production. Okay, that's pretty clear now where it's been updated. Versus this approach where you then merge it, and then you need to make sure that whatever happens after that has been orchestrated in the form of a pipeline, where you systematically promote that change to every environment that it needs to go after that. But now the onus is back on you, that you have to implement something to make sure that happens. In Terraform Cloud, they have this workflow where it will plan in every environment. And then when you merge, then you can set up rules, I believe, on what happens when you merge. So when you merge, maybe it goes automatically out to staging, and then you have maybe a process of clicking the button to apply to the other environments. What's nice about this is you'll still see that has not been applied to those other environments, and you need that somewhere. So whether you use the pull request to indicate that that's been applied, or whether you use a tool like Terraform Cloud to see that it's been applied, or whether you use a tool like Spinnaker to create some elaborate workflow for this, that's open-ended. Let's see, I think we got some more messages here. You've removed the need for such a dashboard by making part of your process ensuring that it's all repositories or environments. Yeah, so I'm still not 100% sure. Okay, cool, awesome. So yeah, Alex says that this alternative strategy we're proposing eliminates some of these needs for doing that. Because in the other model, the process is basically, the onus is on you to have the rigor to make sure these things get rolled out everywhere. And especially the larger your team gets, the less oversight there is, ensuring that stuff happens is hard.
So one thing I'm personally taking away from this is to try the workspace recommended thing on the Terraform docs first.
I think you should.
And report back all the pitfalls.
Yeah. Also, and to be candid, I've not watched or listened to it yet. And you're going to find detractors for this, right? But that's good. In any rich ecosystem, you're going to find. And Anton Babenko is is a prolific, is it FOSDEM or FOS? I forget what the conference is. He has just done a presentation on why you want to go unselling everything I said, I think, saying why you have to have the directory approach. So that might be a video to watch. Anton is a great speaker, and I'll look that up.
I actually met this guy at DevOps Days.
Yep.
Yeah, he was there last year. Yeah.
Super nice guy.
Oh, he's awesome. Yeah, I really like him. I met him up in San Francisco and reInvent. I think this guy goes to like 25 conferences a year or something. It's a lot.
So you were saying he kind of has the recommendation, even with 0.12, to stay with the directory or repo.
I think so. So he's a very big TerraGrunt user. And TerraGrunt is a community in and of itself with their own ways of doing things. So therefore, I suspect this will be very much promoting that. Because in the abstract, it was something like why you have to do this this way. I'll find it though while this is going. Any other questions here?
I mean, I have a bit of a question that kind of is a little bit higher level, but my experience with Terraform is that when you use it, it's kind of very low level. It's like barely abstracted from the API, and you have, of course, you know, the built-in kind of semantics that HashiCorp gives you. Rails, as it were, a sort of like, you know, this is how we do state transitions. This is how we do this. This is how we do that.
Yeah.
And like you have to kind of like, you know, operate inside of that construct.
Yeah.
What's your experience with or thoughts around using higher order constructs like you know, what's available with AWS CDK, for example, and some of the things you could do with that in a fully Turing complete language?
Yeah.
And go ahead.
No, it's good. I like the question, and let's see how I answer it. So this has come up recently with one of our most recent engagements, and the developers kind of on that team challenged us to like, why are we not using CDK for some of the stuff? Let's be totally honest that like CDK is pretty new and we've been doing this for a long time. So our natural bias is going to be that we want to use Terraform because it's just a richer experience. But there's a lot of other reasons why I think one can argue for using it something like Terraform and not something that's more Turing complete like CDK or Pulumi. And that's that requirements don't always translate to awesome outcomes or products. And the problem is that when you can do everything, anything possible, every way possible, you get into this scenario of why people hate Jenkins and why people hate like groovy pipelines in Jenkins. Because you develop these things that start off quite simple, quite elegant, that do all these things you need, and then 25 people work on it, and it becomes a mush of pipeline code, a mush of infrastructure code if we're talking the CDK route and things like that. This is not saying you can't use it. I'm thinking more like there's a time and place for it. So if we talk about Amazon and the Amazon ecosystem, an example I like to bring up is ECS. ECS has been wildly popular as a quick way to get up and running with containers in a reliable way that's fully integrated with AWS services. But it's been a colossal failure when you look at reusable code across organizations. And this is where Kubernetes just kicks butt over ECS. So in Kubernetes, Helm became the dominant package manager in this ecosystem. And yeah, there's been a lot of hatred towards Helm for some security things or whatnot, but it's been incredibly successful because now there are literally hundreds and hundreds of Helm charts, many written by the developers of these things to release and deploy their software. The reason why I bring up Helm and Kubernetes is that's proved to be a very effective ecosystem. If we talk about Docker, same thing, incredibly productive ecosystem. And so with Docker Hub, there's this registry, and security implications aside, there's a container for everything. People put them out there. Your mileage may vary, and some may be exploitable. But that's part of the secret why Docker has been so successful. It's easy DSL, easy distribution platform, and works everywhere. The same pattern, like going back in the days to Ruby gems, and then Python modules, and all these things. It's a very effective pattern. Then we go to Amazon, and we have ECS, and there's none of that. So we get all these snowflake infrastructures built in every organization to spec, and then every company, every time you come into a new company, at least as us, as contractors, no two environments look the same. They're using the same tool stack, but there's too many degrees of variation, and I don't like that. So this is where I think that part of the success of Terraform has been that the language isn't that powerful and that you are constrained in some of these things. And then the concept of modules is that registry component, which allows for great and tremendous reusability across organizations. And that's what I'm all for. And that's like our whole mission statement at Cloud Posse, is to build reusable infrastructure across organizations that's consistent and reliable. So back to your CDK question, and the answer that I gave the customer was this. Let's do this. Let's continue to roll out Terraform for all the foundational infrastructure, the stuff that doesn't change that much, the stuff that's highly, highly reusable across organizations. And then let's consider your developers to use CDK for the end, for like the last layer of your infrastructure. What I'm talking about there, and I'm not sure at what point you joined, but in the very beginning of the call, I talked about what I always talk about, which are the 4 layers of infrastructure. Basically, layer 1, layer 2, layer 3, 4. Layer 1 is foundational infrastructure. Layer 2 is your platform. Layer 3 are your shared services. Layer 4 are your applications. Your applications, go for it. Go nuts. Use CDK, use CloudFormation, use serverless framework. Like if somebody's using the serverless framework, which is purpose-built for doing Lambdas and providing the structure of a Rails, but for Lambdas, use it. I'm not going to say because we use Terraform in this company, you're not going to be able to use serverless. That's not the right answer. So the answer is it's going to depend on what at where you're operating.
Yeah, I really like that that 4-layer model. I missed that from the beginning of the call, but that really makes a lot of sense because you want to have your foundations a little bit more rigid. You don't want to have that mush that you described earlier, and that's where I think like that lower level, the tight constructs that Terraform gives you, the high opinionation, I should say,
exactly
makes sense because you can only do so much, and moreover, you have a pretty mature kind of. It used to be with Terraform that you would have Terraform plan and then your Terraform apply could be quite different sometimes. But I think that's become much more mature at this point.
Yep.
And they really do a good job of predicting when they're going to destroy your shit.
Yeah, and they've added just enough more functionality to HCL2 to make it less painful, which I think is going to quell some of the arguments around Turing completeness. And then the other thing I wanted to say related to that is like the problem we had in pre-HCL2 all the time was count of cannot be computed. That was like the bane of our existence. And like one of our top linked articles in our documentation was like all the reasons why count could not be computed. Now we don't see those much anymore. So I'm a lot happier with that. And the only other thing I was gonna add, and I'm not sure I'm 100% on this anymore. I wasn't 100%, I was maybe 50, 60% before, and now I'm maybe 30, 40. But I was wondering, like, maybe HCL is more of like a CSS language, and you need something like Sass on top of it to give a better developer experience. But for all the reasons I mentioned about CDK, my concern is then we get back into this problem of non-reusable, vendor-locked kind of solutions. And unless it comes from HashiCorp, you run the risk of running afoul of kind of the vision they see for the product. Also, Alex Siegman shared in the Zoom chat. I don't know, Alex, can you post it to the SuiteOps office hours channel as well? Yeah, this is the talk that Anton Babenko did at FOSDEM, and the recording has been posted, and he just posted it to his LinkedIn. I'll look it up after this call and share it if I find it. I do think actually though, boy, this has been a long conversation today. I think we're already at the end here. Are there any last parting questions?
No more, just to thank you. Thanks for calling me out earlier and then taking the whole hour to talk about Terraform. I appreciate that.
Wow, that's great. I really, I really enjoyed today's session as always. So let's see here. I'm gonna just wrap this up here with the standard spiel. All right, everyone. Looks like we've reached the end of the hour. That about wraps things up. Remember to register for our weekly office hours if you haven't already. Go to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. Thanks again, everyone, for sharing your questions. I always get a lot out of these, and I hope you learned something from it. A recording of this call will be posted to the Office Hours channel and syndicated to our podcast at podcast.cloudposse.com. So see you guys next week, same place, same time. Adios.
Thanks a lot. Take care.
Thanks, Eric.
Thanks a lot.